Okay, in this video we are doing Calc BC Problem Set number 7. The problems and a playlist are in the description below. Let's take a look. Number 1, the graph of f prime is shown above. Use it to answer the questions that follow. Find and classify the critical points of f of x. Justify your answers. This is a very A-B level question, so hopefully we can definitely do it. Critical points are when f prime is 0 or undefined in the domain of f of x. Since we have f prime, we're just looking for where it's 0 or undefined. So here, here, and here. So we know the critical points are -2, 1/2, and 3. Make sure you're confident that it's at 1/2. Also, why did I write -1/2? That's positive 1/2. Let me fix that. Can I fix that? Sure, maybe. I don't know. There we go. Okay, positive 1/2. And then we have to classify these things. So I always look to group them together. So like I'll group relative maximums and relative minimums. So in this case, we have 2 relative maximums where f prime is going from positive to negative. So here and also here, f prime is going positive to negative. Those are relative maximums. So let's list those. F of x has relative maximums at -2 and 3 because f prime changes positive to negative there. Let's see if I accidentally wrote -1/2 again this time. We have 1 relative minimum because f prime is going negative to positive, and that's happening at positive 1/2. F of x has a relative minimum at, I wrote negative again, at least I'm consistent, at positive 1/2 because f prime changes negative to positive there. That's all this takes. We want to find the x coordinates of the points of inflection for part B. So points of inflection are going to be the relative extrema. So that's going to be here and here. That's -1 and 2. So this one's straightforward. We're just going to say f has points of inflection at x equals -1, x equals 2 because f prime has relative extrema there. You could also say that f prime is changing from decreasing to increasing or increasing to decreasing. Obviously, that takes a little longer to say, which is why I just go with relative extrema. But either one is totally acceptable. We have the graph of f prime, so I don't want to talk about f double prime. I know a lot of people love to just use f double prime as their reasoning. I think given f prime, base it on f prime. If you're given f double prime, then obviously we'd be looking at sign changes for f double prime to find points of inflection for f. All right, let's look at the next part. Same setup. C, determine the intervals on which f is decreasing concave down. So decreasing means f prime is negative. Concave down means f prime is decreasing. So I need f prime to be negative and decreasing. So here and here. And now we're just going to write that up. So what is that? -2 to -1 and then 3 to 4. So we will say f of x is decreasing concave down on -2 to -1 and 3 to 4 because f prime is less than 0 and f prime is decreasing on those intervals. That's all that requires. Part D, if f of 1 is 8, we want to find f of 4 and f of -2. We're basically going to use the fundamental theorem here or the concept of, I guess, displacement, right? So f of 4 is going to be where you start plus the displacement. So it's going to be f of 1 plus the displacement from 1 to 4, which is going to be, so f of 1 plus the integral from 1 to 4 of f prime of x dx. Now we got to calculate this. So I'm going to break this up a little. I'm going from 1 to 2, and then 2 to 3, and then 3 to 4. So from 1 to 2, it's a trapezoid, so it's 1/2. The height is 1, that's from 1 to 2. And then the first base is 1, and the second base is 3. So 1/2, 1, 1 plus 3, so that's 2. Then we have a triangle, it's 1 by 3, so 1.5. And then we have a triangle that is 1 by -2. I had to erase that to be sure. I mean, I was pretty sure, but 1 by -2, so half of that is -1. Which means that we are doing f of 1 was 8, plus we get 3.5 minus 1 is 2.5, so 2.5. So overall, we have 10.5. All right, and then we'll do the same thing basically for f of -2. So f of -2 is going to be where you start, which is f of 1, and then plus the displacement, which would be the integral from 1 to -2, but we don't want to do that, right? So we're going backwards this time, so we'll do minus the integral from -2 to 1. So if you're going forward, you add it. If you're going backwards, you subtract it. Lower bound should always be smaller than the upper bound. Now we got to find this. So same thing, I'm just going to divide things up. So that is a triangle that is 1 by -3, and then half of that. And then we got this situation going from 0 to 1, where by symmetry, these two triangles are the exact same size but have opposite sides, so they just cancel each other out, so we don't need to worry about that. So what we do need to worry about is this trapezoid that is basically the same trapezoid as the one that we got from 1 to 2, except below the axis, so we'll get -2 instead of +2. So we're going to have our value, which was 8, and then minus -3.5, which is 8 plus 3.5, or 11.5. So this is a really common thing to do. Now, part E, I think, is interesting because it's almost the same question. We want to find f of 4 again, and we want to find f of -2 again, but this time f of 1 is 10 instead of being 8, so it's 2 bigger. So if you think about it, if the initial value is just 2 bigger, all of our answers should just be 2 bigger than the previous answers that we got. So I'm going to do our value here, which is 10, and then our integral from 1 to 4 did not change. It's still 2.5. So we get 12.5, which is 2 bigger than the 10.5 that we previously got. And then when we do this next one, f of -2 is going to be f of 1 minus the integral from -2 to 1 f prime of x dx, which is 10. And then it should be minus, again, -3.5, but I'm just going to add 3.5 this time to get 13.5, which again is just 2 bigger than what we had. If the initial value was like 14 smaller, then the answers we expect to get would just be 14 smaller than the previous answers. So just playing around with that concept, making sure that you understand it. Let's take a look at the next part. So the function g of x has a third degree Taylor polynomial, which is called p of x at x equals -3, which is shown above. All right. Determine if g of x has a relative maximum, minimum, or neither at x equals -3, and justify. All right, so look at p of x. You can see that there is no x to the first term, right? There's no x plus 3 to the first. The reason there's no x plus 3 to the first must be because the derivative g prime of -3 must be 0, right? Because in general, we're always looking at the nth derivative at -3, x minus -3 rather, to the n over n factorial. So if there's no term, the only option there is that the derivative was 0. So since there is no x plus 3 to the first, we know that g prime of -3 is 0. Now that's important because we can figure out if g double prime of -3 is positive or negative. So that'll be based on this. So remember, that is the second derivative over 2 factorial. The coefficient of x plus 3 to the second is the second derivative over 2 factorial. The coefficient of x plus 3 to the 53rd would be the 53rd derivative over 53 factorial. So in this case, we have this. So we definitely know that g double prime of -3 is actually -8. That's important because now we can use the second derivative test. Second derivative test is extremely common to use when you're dealing with series in particular. You almost never do the first derivative test. Second derivative test almost all the time. So the first derivative is 0. The second derivative is negative, which means we are concave down, which means we must be at a maximum. So since g prime is 0, g double prime is -8, which is less than 0, g of x has a relative maximum at x equals -3. All right, let's take a look at part B, which actually, when I was writing up the answers, I realized if you just did part A correctly, part B is kind of dumb, but we want the exact value of f triple prime of -3, or explain why it can't be determined. So sometimes on the AP exam in the past, in the way past, I can think of some examples, they'll ask you to do this, but not at the center. They'll say it like -2. The answer for a Taylor polynomial, everywhere except the center, will always be that it can't actually be determined. It can only be approximated. In the case of the center, you can always exactly determine it because the polynomial and the function have the exact same values of the function and the derivatives at the center. So in this case, we can find it, and it's going to be based on the -6. So it's going to be the third derivative over 3 factorial is going to be -6. And then 3 factorial is 6, so the third derivative must just be -36. So, I mean, if you did part A correctly, you definitely could have done part B. I don't know. Also, why did I label it part C? Who knows? All right. Anyway, I hope this was helpful, and good luck.